Oscillations and waves. What are the types of oscillations we have and what are waves? This particular concept we are dealing with. In fact, when we consider the motion of different bodies, there are different types of motions which we used to observe. For example, a body is said to have periodic motion. What is this periodic motion? First of all, a body can have harmonic motion. What is that harmonic motion is the next concept. And what is a simple harmonic motion of a body? What are the individual features of all these different types of motions of a particular body? When we consider periodic motion, first of all, what do you mean by periodic motion of a body? When we observe the motion of a body is repeated itself at regular intervals of time, then we can call it as periodic motion. I repeat, when the motion of a body is repeated itself at regular intervals of time. What do you mean by this? For example, when we consider an electron in a particular orbit moving around a nucleus, whatever time it is going to take to complete one rotation around the nucleus in a particular orbit always is going to be a constant. That means one can understand when the particle like electron is just taking the same time to complete one rotation around the nucleus, one can say the motion of that electron as a periodic. In the same manner, we all in fact know every planet revolves around the sun. The time period of every planet to complete one rotation around the sun always is going to be constant. That again can be called as a periodic. Exactly in the same manner, if you take Earth, when it is spinning on its own axis, it takes exactly 24 hours for it to complete one rotation. This particular concept of the motion of the body, which is of course repeated itself at regular intervals of time, that is what we call it as a periodic motion. So, we can just take examples like electron revolving around the nucleus. That is one of the best examples. Similarly, you can even take the concept of a planet which is just revolving around the sun. This is actually the position of the sun. If I consider this is of the planet, directly you can understand the motion of that planet around the sun is also called periodic. Now the question next is, when can we call this one as harmonic? When can we just call the motion of a body as harmonic? In fact, in mathematics, sine function and cos function, which are basic trigonometrical functions, we call them as harmonic functions. If we represent the motion of a body either in terms of a sine function or in terms of cos function, then we can call the motion as harmonic motion. For example, when we consider the oscillation of a pendulum, that of course we can say it is harmonic oscillation. What is the reason? That oscillation of the pendulum, one can either represent in terms of a sine functional wave equation or in terms of cos functional wave equation. So, whenever we consider the motion of the body in terms of sine function or cos function, we can call the motion as harmonic by nature. So, if you consider this either in terms of sine function or in terms of cos function, when we consider generally, what are the values? Sin 0 is 0, sin 90 is 1, sin 180 is going to be 0, Sin 270 is going to be minus 1. Sin 360 is going to be once again 0. If you just consider 0, 90, 180, 270 and 360, what are these values for a cos function? Cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, cos 360 is plus 1. When I consider the oscillations of a pendulum this way, as an example, let us consider this way. When the pendulum is oscillating, the oscillations can be counted in different ways. I am just going to explain you two cases out of all. One, let us consider this way. It is starting from rest, it goes to that end, comes back like this to the original position, goes there again and comes back to the original position. So this is one, what we can call it as an oscillation of the pendulum. What is the other method of counting the same? I just give you the other one as well. I start from extreme right, it goes to extreme left and comes back again to right. Now in this particular position also, we can count this one as one oscillation of the pendulum. So when we consider the oscillations of a simple pendulum, one should understand that the oscillations can be counted in many ways. These are the two different examples what we are considering. So when we take this oscillation is just taken up this way and coming back like this, that is one method of counting. Going to extreme, coming back to the mean position, going to other extreme, coming back to the mean position, this is what we can call it as another oscillation like. If you just take in terms of angle, at the mean position of rest when I consider the angle to be 0, then this particular oscillation can be represented in terms of a sine functional wave. What for you can guess it? Sin 0, 0, sin 91, that is 1/4 of an oscillation. Sin 180 again 0, sin 270 is minus 1 and sin 360 is 0. This is exactly similar to the concept of sine functional values. Therefore, one should consider this type of an oscillation in terms of sine functional wave equation. Similarly, when we take this one, it is from extreme it is starting. So, cos 0, in fact, we can just compare this one with cos functional values. Therefore, cos 0 is going to be 1, cos 90 will be 0, cos 180 will be minus 1, once again 270 will be 0 and 360 will be plus 1 again. So what is it happening? The moment we are considering that this oscillation is taken like this from right to left and once again it is coming back this way from left to right, this is one complete oscillation. When I consider like that, definitely we can say this is exactly similar to the values of cos function. Therefore, we can consider this type of a wave motion or the oscillation of this particular body, we can take in terms of sine functional wave and this one in terms of cos functional wave. So, such a motion in which we are considering the motion of the body either in terms of a sine functional wave or in terms of cos function, that is what we call it as a harmonic motion. Now, the question next is, what do you mean by simple harmonic motion? The simplest form of harmonic motion, that is all, nothing special as such. What do you mean by this simple harmonic motion? When can we call that the motion of the body as a simple harmonic? There are three conditions we have to remember to call the motion as simple harmonic. What is the first condition? If the acceleration of the body is directly proportional to its displacement. So, what is the first condition here? The acceleration of the moving body is supposed to be directly proportional to its displacement. And what is the second condition there? The directions of these two are supposed to be opposite to each other. That means once again I can repeat the same this way. The acceleration of the body, if it is directly proportional to its displacement, taken in opposite direction, that is the second condition. What is the third condition? The acceleration of the body always is supposed to be towards the mean position of rest of the body. So, if at all the acceleration of a body which is in motion is directly proportional to its displacement in opposite direction and always directed towards the mean position of rest, then we can call the motion of the body as a simple harmonic by nature. So, simple harmonic motion is the major one or major concept what we are discussing in this particular chapter called oscillations and even waves. So, what is a simple harmonic motion? What are the conditions and what are the equations which we require for observing or for obtaining SHM of a body? These are the areas we are going to deal with in a detailed manner in this chapter as such.